Professor Dr. N. Ganesh is working as a senior faculty, Department of Computer Science and Engineering, SRM University, City Campus, Vadapalani, Chennai. He has more than 12 years of undergraduate and postgraduate teaching experience, which includes 5 years of research experience. He has trained many corporate batches on technologies such as mainframes, Application Systems 400, SAP, ABAP. He has published 10 articles in both international and national journals. He has presented several papers in both national and international conferences. He has written 4 books which are prescribed in Anna University affiliated colleges, SRM University and Bharat University. His research interests are software engineering, data mining and cloud computing.
Welcome to the UGC lecture series in computer science. We are going to see a series of lectures in the subject operating system. This subject is for the BSc students who are doing their 5th semester degree program. So this subject is of paper 8. We are going to see a few topics from unit 1. So there are many topics in unit 1, out of which in today's session we are going to see 2 different topics. One is about threads, other one is client server communication. So today's contents, it will be about the communication in client server system, about what is a thread, what are the features of thread, single and multi-threaded processes, benefits of using a thread, multi-core programming, types of threads and multi-threading models and the different models pertaining to multi-threading concept. So now first and foremost about the communication in client server system. In our previous session, we have seen 2 different types of communication in client server system. They were the sockets. I explained about what is a socket, how a socket communication takes place, and we as well seen another type of communication system called the RPC, remote procedure calls. So in today's session, we will be seeing third topic, the pipes. What is a pipe? What are the different types of pipes available? The pipes is classified into 2 different groups. One is called as a ordinary pipe, other one is named pipe. So what is an ordinary pipe? So what is a pipe first of all? How communication takes place between pipes? I suppose you would have seen a pipe. Okay, so if you are going to see a pipe is a physical pipe, a generic pipe, say for example, wherein the communication takes place in terms of a producer-consumer relevance, simple producer-consumer problem. So what is a producer-consumer problem? A producer is one who produces and a consumer is one who consumes the whatever the producer has produced. So this is unidirectional. This ordinary pipe is said to be unidirectional. So in which we are going to see 2 different types of pipe. One is ordinary, other one is named pipe. So we will see with respect to a diagram. So this is an ordinary pipe. Before we see this ordinary pipe, an ordinary pipe allows communication in standard producer-consumer style. A producer writes to one end, the right end of the pipe. The consumer reads from the other end, the read end of the pipe. Ordinary pipes are therefore unidirectional. It is not bidirectional, it is only unidirectional. It requires parent-child relationship between communicating process, which means you can send the data only from one end and you can receive the data on the other end. So on that one particular end, data can be sent by both by the parent as well by the child, and on the other end, data can be received by both the parent as well the child. So here it shows. Here this is said to be an ordinary pipe, wherein this is said to be a parent. FD is said to be the fork data of 0, FD of 1. So here this FD of 0 parent sends a data. So this has been sent by this particular area. So he is producing it, right? And this child, FD of 0 over here of the child, he sends the data on the same end as that of the parent. So he even produces it. And then at the other end, it is used by the consumer. So this parent FD of 1 consumes the data on the other end, and here this child on the other end consumes the data from this end. So from here the data has been sent, and here in this end this has been received. So this is called as an ordinary pipe, wherein it is only unidirectional. It goes only via the left hand side and reaches the right hand side. It can be either way. It can go via right hand side and reach the left hand side. But the thing is, it is only unidirectional. It is not bidirectional as far as ordinary pipe is concerned. Whereas a named pipe is concerned, it is bidirectional. A named pipe is said to be, it is a powerful tool where you give in certain names for both the pipes, for both the processes. So what happens is that you from one end, if is going to send a message and from the other end is going to receive, we will be knowing who has sent it and who has received it. So that is the specialty of a named pipe, and here it is. This named pipes are more powerful than ordinary pipes. Communication is bidirectional. No parent-child relationship is necessary between the communicating processes. Several processes can use the named pipe for communication. So it is exclusively used in the Windows and Unix operating systems. This is more common in the Windows and Unix operating system. So and it is more powerful because it has been named. Say for example, if I know certain people name, I can call them with the help of name. Instead of calling them without name, if I'm going to just call them in the group, I will not be in a position to exactly pinpoint a particular person and call that particular person. So I suppose you might be knowing the difference between knowing the names of a person and calling them, and without knowing the name of a person and then interacting with them. So which will be more powerful? I suppose knowing the name of a person and interacting with them will be more powerful, in such a way that knowing the name of process and then communicating is more powerful than an ordinary pipe. And one more important point over here is it is multidirectional. It is two-way directional, bidirectional. Whereas in the case of ordinary pipe, it is unidirectional. So this is about the communication system with respect to the client server system. And now the next topic is on thread. What is a thread? I suppose you would have learnt about process. Now we will learn about a thread. A process is said to be a heavyweight, whereas a thread is said to be a lightweight. A process is a program in execution. A thread is a line of execution. So from this you can make a note. A process is a program in execution. A particular program has n number of instructions to be underneath, whereas a thread, it is only a line of execution. So for each and every for you will be having many instructions. So each and every instructions will act as a thread, and that is the thread. And now we will see a definition of a thread. A thread is the smallest unit of processing that can be performed in an operating system. In most operating systems, a thread exists within a process. That is, a single process may contain multiple threads, because as I said, a process, you will be having set of instructions, whereas thread is a line of instruction. So line of each and every line in that program acts as a thread. So what are the features of thread? So features of thread is multiple threads run in a single application. So one particular application have multiple threads. So what is the advantage of using these threads? You can easily update, you can easily fetch the data, you can easily display the data. So these are some of the features available in the threads. So here it is: update and display, fetch the data, spell checking, answer a network request. And the process creation, as I said, the process is a heavyweight, whereas thread is said to be lightweight. The thread is used to simplify a code and increase the efficiency level, whereas the kernels are generally multi-threaded. What is a kernel? I said in the previous session itself, a kernel is something like it is a nucleus of an operating system. A kernel is one. I gave you an example with respect to a coconut, wherein when you break open the coconut, you have an inner whiter region of a coconut inside the shell. That white region, you call it as a kernel. It is the inner part of an operating system, or it is the inner part of it, is what you are going to use it. So only you will not be using the outer part, you will be using the inner white layer of the coconut for your cooking purpose. So in such a way that this kernel operating system, this kernel is the acts as a prime source for the operating system. So this kernel has multiple threads, and then let us see the single and multiple thread processes on a diagrammatic way. So as a single thread, in each and every thread you have the stack and registers available in both in single thread as well in a multi-thread. So let us see a single thread and multi-thread diagrammatically. So this first diagram shows a single thread process wherein you have a program code, a data, files used for this particular program. So underneath this you have a register and a stack. So this is our thread, a line of execution. Whereas this example, this diagram shows a multiple thread wherein you have a common code, common data, common file. But when you are going to use it for multiple purposes, then you call it as a multiple thread, wherein you have individual register and individual stack for each and every thread. So here you have a common stack and common register because it is only one thread, so you have only one register and one stack. Whereas in this case, for each and every thread you have separate register and separate stack, separate register and separate stack. For thread 3, separate register and separate stack. Whereas you have a common code, data and files are common, but this register and stack is to be separate for each and every thread. Now, what are the benefits of using a thread? You have a faster response time. The responsiveness is pretty fast. You can share resources very easily, and then you have a good economy, and then it is stable. So you have a stability purpose, and then so this is about the benefit of a thread. Now, what is a multi-core programming? So what do you mean by multi-core programming? What is a single core? What is a multi-core? I suppose in your computers, when you are going to purchase a computer, you would have asked for processors. People say it is dual core, core 2 duo, quad core. What does it mean? The processor speed. So it is more faster when compared to a unique core, when compared to a single core. In the early days, you had Pentium 1, Pentium 2, Pentium 3. Even before that, we have 386 and all. But let us consider with respect to Pentium 1, Pentium 2, Pentium 3, wherein you had only one processor. We had Pentium 4 even. And then came in a concept of dual core. Then came in a concept of core 2 duo. Then came in a concept of quad core. So, which means that what is a quad core? Quad core is a processor. In your CPU, you have 4 different processors. So, if you are going to have 4 different processors, then what is the speed of execution of your program code? It will be comparatively highly fast when compared to using a single core system. So, now let us see a topic on multi-core programming. What is a multi-core programming? A multi-core system putting pressure on programmer challenges include. So, say for example, you have a scenario here. You have a task. You are working in a software company. Let us consider, and your project manager assigns a task. He has a big project. How will he assign it? He will be splitting into different sectors, different tasks, and he will be assigning equal weightage for each and every member. So, say for example, one particular person will be asked to code, one particular person will be asked to create a front end, one particular person will be asked to create a back end, so on and so forth. So, you are dividing, sharing the resource, and in such a way, what is the aim of it? In order to complete the project at a faster pace. Supposing if the project manager has a project, he has got a project, and if he is alone, he is said to be the project manager, if he is said to be the developer, then he will take more amount of time to complete a particular project when compared to splitting the resource and executing and then combining and getting the things. So this is about multi-core programming. We will see more details on this multi-core programming or the multi-threaded server architecture after the break. Welcome back after the break. We were seeing about the multi-core programming and its features. I gave you an example before the break. I gave you an example with respect to assigning a task to each and every individual. If there is a project, splitting the project into equal divisions and then assigning it to many different people so that we can get the end result at a faster rate rather than working it on an individual basis. Now let us see a multi-threaded architecture, server architecture, how it works, and then we will link this with a multi-core programming. Here it is. In this multi-threaded server architecture, this is a client. He gives a request to the server. So the server, it creates a new thread to service the request. So thread is a line of execution. So after it creates a new thread, after creating a new thread, this gets executed. So now with this, the job of server does not end. So it has to wait for additional request whatever the client gives. So this is what is resume listening for additional client request. So for each and every client request, each and every request obtained from the client, the server will be creating a new thread to service the request. Now with respect to the earlier example, we will see diagrammatically how it relates with respect to the operating system. A project example I said, we can relate it with our operating system thread concepts. Here it is. So here the concurrent execution on a single core system. If I am going to have a only unique core, if it is of a single core, if I gave you an example with respect to a single person doing an entire project, if he is going to do an entire project, then the time taken for him to complete the project will be more. So similarly, if it is of a single core, then consider these are said to be the threads T1, T2, 3T, 3, 4. So thread 1, thread 2, thread 3, thread 4. After completing this, he has to again take the next set of execution, next set of instruction, thread 1, thread 2, thread 3, thread 4. Similarly, he has to continue. So it takes more amount of time for a single core. If it is of a parallel execution in a multi-core system, something like a dual core system, then core 1, processor 1 will be executing thread 1. Processor 2, core 2 at the same instance of time will execute T2. Core 1, then after completing T1 it will start executing T3. Core 2 after completing T2 will start executing T4. So T3 and T4 will get executed simultaneously. T1 and T2 will get executed simultaneously, and so on and so forth. But when compared to the previous example, in the previous example, here after completing all the 4 threads only, the second set of instruction gets executed. Whereas in this case, 2 threads get executed simultaneously. That is a parallel execution on a multi-core system. Now let us see what are the different types of threads available. We have threads are majorly classified into 2 different types. One is called as a user thread, other one is called as a kernel thread. What is a user thread? A thread that is being used by the user is called as a user thread. So a thread management which is being done by the user level thread library. There are 3 different libraries available. One is called as the POSIX pthreads. So POSIX pthreads, Win32 threads which is being used for the Windows operating system, Java threads which is being used by the Java language. Then they are about the kernel threads. This is about a user thread which is being used by the user. Next about the kernel threads. As far as a kernel thread is concerned, which is being used by the kernel of the operating system, which is being used by the nucleus of the operating system, is called as a kernel thread. So here it is being supported by the kernel. For example, the Windows 2000 operating system, or the Unix operating system, or the Solaris operating system, or the Linux operating system, Mac OS, everything. If you're going to have an operating system, then definitely you will be having a kernel thread, because to execute any set of program, if you want to just open, or if you want to just operate a computer, definitely you need to have an operating system. Let us be a disk operating system, let us be a Windows operating system, let that be a Mac operating system, let that be a Unix or Linux or Solaris or whatsoever it may be, anything for that matter. If you want a system to get operated, to be in a working condition, that operating system should function. So for the operating system should function, in order to function, it has to have certain threads involved in it. It has to, certain processes have to be run at the background of the operating system. Then only an OS can perform well. So such a process which runs on the background of the operating system, in order to make the operating system to function well, we call it as kernel threads. So which is said to be a very important thread as far as the types of thread is concerned. Whereas a user thread is concerned, it has been created and been used and been destroyed by the user. Whereas an operating system thread, kernel thread is concerned, we cannot destroy a thread. If you are going to destroy that kernel thread, then definitely we will not be in a position to use the operating system again. So next is the multi-threading models. As far as the multi-threading models are concerned, it is broadly classified into three different type of models. One is called as a one-to-one model. Second one is called as a many-to-one model. Third one is called as many-to-many model. So what is a many-to-one model? In a many-to-one model, many users will interact with many user threads will interact with the single kernel. So there are user threads, it's been many users are interacting with a single kernel thread, that is called as a many-to-one model. What are the examples of many-to-one model? Where has it been used as? It is being used in the operating systems like Solaris green threads and GNU portable threads. So this is how it looks. So these are the different types of threads. These are the user threads created by user, and this is said to be a kernel thread. Next is said to be the one-to-one model. In the one-to-one model, wherein one thread will be used by one kernel. So single user thread is being used by a single kernel. For example, it is being used in operating systems such as Windows NT, Windows 2000, Windows XP, and so on. As well, it is also used in operating systems such as Linux and Solaris 9. And this is how it looks. So you have the user threads and these are the kernels. For each and every thread, the kernel will be responding. So what happens is that when compared to the previous model, in this model, many threads are being used by the single kernel thread, and the execution time is pretty faster when compared to this, because it has to serve each and every thread for one particular instance of time. Only it can serve only one thread, whereas in the other case many threads are possible. Then the next model is said to be the many-to-many model. In the many-to-many model, many threads uses many different kernel threads. So many user threads can interact with many different kernel threads for its execution. So for even in the operating systems like Windows NT, it uses those many-to-many threads, and even this Windows 2000 uses many-to-many threads. Many user threads have been used by many kernel threads. So this is how it shows. So many user threads are being used by many different kernel threads. And like Solaris version prior to version number 9, it uses this kind of many-to-many model. So we are seeing about the multi-threading models. In this multi-threading model, we were seeing three different models. One was one-to-one, other was many-to-one, third one was many-to-many. So what did you infer from this? If it is a one-to-one, serving the concept, serving the operating system or the thread, it has to, this kernel, it will be interacting only with one thread. So when it is going to interact with a single thread, then the other threads have to wait in queue. That consumes more number of waiting hours. So the execution time will be more, as well the efficiency level will be very less, because it is consuming more amount of time. So that is a disadvantage of using an one-to-one model, but that was being used in certain operating systems in the earlier days. So as an advantage, this kernel, it is going to act only with that one particular thread. So what happens in that, when it is going to interact with only with one thread, so it can suffice or it can serve all the needs of that particular thread. That is said to be a one-to-one. Whereas in the case of many-to-one, that is many different threads in the sense, many different threads of a same program from a same set of instruction, or many different threads of a different set of instructions. will be interacting with an kernel thread. So if I am going to have it as a many different threads that has been interacting, many different threads is called as a multi-threading. What is the difference between single thread and multi-thread? A single thread is a line of execution of one particular line will get executed. It's called as a thread. Whereas multi-thread is nothing but two or more number of lines getting executed simultaneously at the same instance of time. You call it as a multi-thread. So here many different threads, maybe it may be from a single program instruction, from a single process is nothing but you have a program execution from a single process, or it may be from a multiple two or more number of processes. If I am going to take each and every line from one processes and then make it to interact with this kernel thread, then it is an example for a multi-threading model with many to one example. Many threads, many user threads, many thread created by a user gets executed to a single thread that is available in the kernel. So many user thread to a single kernel thread. That is an example that has been used in operating systems such as Windows NT, Linux, Solaris 9, so on. And the next one is about many to many. Many to many is here many threads from either again from a single process, many different lines can interact with many different threads that is available in the server, or from a different process. Say for example, I have 4 different processes, P1, P2, P3 and P4, wherein in 4 different processes, if I am going to take the first line of program from process 1 and fourth line of program from process 2 and second line of program from process 3 and third line of program from process 4. So all these 4 lines of code get synced together and it interacts with the kernel with many different threads that is available in a kernel. The kernel thread, we do not have an access to change the kernel thread when it is in execution, because we are allowed to create only the user thread and not the kernel thread. The kernel thread it has been created when you are going to install a particular operating system. So we will not be in a position to change the threads of a kernel, threads of the operating system. If at all, if you are going to change the thread of an operating system, if you make a try, then definitely you will end up with problems and your operating system will not be working fine and it will not support our user thread. So we will not be having an syncing with the kernel thread. So we can very well manipulate the user thread. So many different user threads interact with many different threads of a kernel, then such a concept we call it as many to many, wherein it is many user thread gets mapped with many different kernel threads. So that is called as a many to many threading, multi-threading model. So these are the 3 different models that are available under a multi-thread. So now let us summarize whatever we have seen in this session. So first we have learnt about the piped communication and its types in a client server system. So the remaining 2 types of communication we have learnt in the earlier session, that is about the socket system and about the remote procedure call we have learnt in the earlier session. In this session we have learnt about the piped communication system. Then we have seen about the threads and its features of thread as well the benefits of thread. We have also seen about what a single thread is and what is a multi-threading is, and we have discussed about the multi-core programming. We have seen the different types of thread. One is a user thread, other one is said to be the kernel thread. We have as well learned about the different multi-threading models. One is one-to-one, many-to-one, many-to-many. Then these are the possible questions that are possible from this session. That is question number 1. Name the different types of pipe communication in the client server system. Different types of pipe communication system, we can say it as an ordinary pipe and a named pipe. Then second question, what is a thread? Third question, what are the benefits of thread? Fourth, what is the difference between a thread and multi-thread. Fifth, what are the different types of threads? Sixth, list the various multi-threading models. So these questions are possible from this session. So with this, we conclude the session, and in the forthcoming session, we will be seeing further topics on operating system.